In this video, I'm going to go over the basics of complex numbers. And complex numbers are one of the number systems, and we have it listed down here. So before we get to complex numbers, let's go through this entire list. The first set of numbers that we are familiar with when we first start learning how to count is the natural numbers, and the set of natural numbers begins with 1, and it just goes on like this: 1, 2, 3, 4, 5, etc. Okay, so when you first learn to count, these are what you learn. When you were learning to count, you didn't say, "I know all the natural numbers." Sometimes they were called the counting numbers. Okay. Next set we have is whole numbers. So the whole numbers are exactly the same as the natural numbers, but we have one additional item. So these begin at 0 and then continue on to infinity. Okay, so the whole numbers just have 0 tacked on there at the start. Next up, we have the integers. Integers are all the negative whole numbers and the positive whole numbers. So from negative infinity, and we're counting -3, -2, -1, 0, 1, 2, 3, etc. So those just go in both directions from 0. Next up, we have the rational numbers, and we can remember what the rational numbers are by focusing on what the root word of rational is, which is ratio. So remember, a ratio is anything that is a fraction. So technically speaking, a rational number is any number we can write. So let's say let A and B be integers. Okay, so just something in that set. So a rational number. So a rational number is anything that can be expressed as A over B. So where A and B are integers and where B is not 0. So anything that we can express as a fraction with integers. So some examples of this are 1/3 or -4/5. 5 is also a rational number because we could write that as 5 over 1. So these make up the rational numbers. Next, we have the irrational numbers, and I'm running out of space here, so I'm just going to write it down here. So irrational numbers, these are the numbers that we cannot write as A over B. So these are numbers that cannot be written as A over B with B not equal to 0. Okay, so these are the things that we can't write as fractions. So some examples of that are, well, pi. I can't write a fraction with integers that is equal to pi. Square root of 2, square root 3, square root 5. All of these are, if you type these into your calculator and you have a big enough or a powerful enough calculator, that will produce a decimal that just continues on forever. The exponential constant e is an irrational number. So those are some examples. All right. Then we get to the real numbers. And one way I like to explain the real numbers is, and this is probably not a very technical definition, but a real number is anything, maybe not anything, any number that has a location on the number line. So looking at the number line, 0 is a real number. All of the numbers we've talked about so far are real numbers, right? 1, 2, 3, those are all there. Square root of 2, that has a spot on the number line. Pi is maybe over here. Okay, 1/3 is here. -3 is over here. So all of the rational, irrational numbers, integers, whole numbers, natural numbers, those all make up the real numbers. These are the numbers we have worked with most often in algebra and pre-calc. Then all the numbers that are not real numbers are made up of complex numbers, or make up the complex numbers. So the complex numbers are numbers, let me be more precise. So let's say let A and B be real numbers. So a little different than what we said about the rational numbers. So in this case, A and B are real numbers. A complex number is written as A plus BI, where I is the square root of -1. Okay, so that's the big new concept here with complex numbers is, what do we do when we have the square root of -1? Well, we assign the variable I for that. So I represents the square root of -1, and that is not a real number because there are no two real numbers that we can multiply together to give us -1. So the square root of -1 is undefined in the real number world, but in the complex number world, we define that as I. Okay, so I guess I could have used this space down here for that, but there is the definition of a complex number. All right, so let's talk about how we can work with complex numbers. So let's say usually we assign a complex number with z. So let's say z1 is 5 minus 3i. z2 is 4 plus 2i. Okay, so if I wanted to add these two together, it's pretty straightforward. We're going to say z1 is 5 minus 3i, and then I'm going to add that to 4 plus 2i. And it's kind of like we're adding like terms. So the 5 and the 4 becomes 9. Negative 3i plus 2i is negative 1i. So that would be how we can add those. If I want to subtract these, let's say z2 minus z1. We're going to say 4 plus 2i minus 5 minus 3i. The only difference here is we want to distribute this negative through. So 4 plus 2i minus 5 plus 3i, and then just combine like terms. I get negative 1 plus 5i. Okay, so like we said, all of these complex numbers are in the form a plus bi. So on this first one, the addition, we're going to say a is 9, b was negative 1. Down here, a is negative 1, b is 5. So b is the coefficient on the I term. Okay, now let's multiply these together. So z1 times z2. And what are we going to have? So 5 minus 3i times 4 plus 2i. So because these look like binomials, I'm going to distribute or FOIL. So 5 times 4 is 20, plus 5 times 2i is 10i. Negative 3i times 4 is negative 12i. And then negative 3i times 2i is negative 6i squared. Okay, so I can put the 20, bring that down, no other constants. 10i minus 12i is minus 2i. And now this right here is something new that we haven't talked about yet. So remember, our definition of I was the square root of negative 1. If I square both sides, I get I squared is equal to negative 1. So this I squared is equal to negative 1. So what we have in that term is negative 6 times negative 1 is positive 6 here. And then that 6 and the 20 can be combined. So this is 26 minus 2i as the product when I multiply those two things together. And also notice that this is in the form a plus bi now. All right, lastly, I'm going to divide these complex numbers. So z1 divided by z2. We're going to have 5 minus 3i divided by 4 plus 2i. So again, I want this to end up in a plus bi form. So what we have to do is we need to get the I out of the denominator, and I do that by multiplying by the conjugate. Remember, the conjugate is just the same two terms here in the denominator, but I change the operation. So because it's a plus, originally I'm going to multiply by minus. If it was minus, I would multiply by plus. Okay, and then I'm just going to multiply the tops and bottoms together. So I get 20 minus 12i minus 10i plus 6i squared. And then we'll simplify that here in a minute. And then in the denominator, 16 minus 8i plus 8i minus 4i squared. So what's going to happen when we multiply by the conjugate? These middle terms are always going to cancel. And then I squared is negative 1. Okay, so in the denominator, we're going to have 16 minus 4, but that negative 4 is going to multiply by negative 1. So it's 16 plus 4 in the denominator. Okay, and then in the numerator, similar idea. This is going to be negative 1. 6 times negative 1 is negative 6. Negative 6 plus 20 is 14. And then I can combine negative 12i and negative 10i to become negative 22i. Now, this still doesn't quite look like it's in a plus bi form. But in the numerator, I have 14 minus 22i. In the denominator, I have 20. And so what I'm going to do is I'm going to split that fraction into what we call the real part. So 14 over 20 minus 22i over 20. And I can combine those to be 7 over 10 minus 11 over 10i. And that would be the full simplification. So what we see is a is 7/10, b is negative 11/10. All right, so one of the most common ways that we're going to use I is when we're solving quadratic equations. And so let's do these examples and we'll see when and where I shows up. So in this first one, x squared plus 4 is equal to 0. I'm going to just subtract the 4 from both sides and then take the square root. So I'm left with x. When we take the square root of both sides, we end up with a plus or minus here. Now the square root of negative 4, I can think of that as the square root of negative 1 times 4, and 4 can come out as 2 when I take the square root of that. So this will be plus or minus 2, and then what's left over, that square root of negative 1, well, that's I. So this solution is plus or minus 2i here. On the second equation, this is a quadratic equation. I can't use the square root property like I just did. I also can't factor this, so we need to use the quadratic formula. We're going to where a is 1, b is 2, c is 3. So as a refresher, x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. So that's our quadratic formula. So x is going to equal opposite of b plus or minus square root b squared. So 2 squared is 4 minus 4 times a times c all over 2 times a, which is just 2. So simplifying this down, I get 4 minus 12 in the radicand here. 4 minus 12, that's negative 8. Okay, so because I have a negative under the radical, that's when I'm going to need to use I. So I'll kind of simplify this over here. So the square root of negative 8, I can rewrite that as the square root of negative 1 times 4 times 2. And the reason I do that is because I can take 4 out as a 2, and I can take the negative 1 out as I. So what we get there is 2i square root 2. So putting that back into the quadratic formula, you have negative 2 plus or minus 2i square root 2 divided by 2. And then each of these 2's here I can factor out. So I can divide each of those by 2. So I get negative 1 plus or minus I square root 2. I can write this over 1, but I don't have to. So that is what x is going to equal for that quadratic equation. All right, and then there's one last thing here. How do we simplify the different powers of I? Well, we saw that I to the first, well, that's just I, which is the square root of negative 1. I squared, if I square that, I get negative 1. I cubed, well, that's just these two things multiplied together. So that's going to be I times -1, so that's negative I. And then I to the fourth, that's just I squared times I squared. So -1 times -1 is +1. Okay, so if I keep going, what we're going to see is all of these things just repeat themselves. -I and 1. Okay, so we could keep going every fourth, every time we have a new power, it just keeps going in this cycle. Okay, so if I want to evaluate I to the 35th, because every time we have a new power of kind of another copy of 4, it repeats itself. So what I do here to evaluate I to the 35th, what we do is we take 35, we divide it by 4, and that goes in 8 times. 8 times 4 is 32, and the remainder here is 3. So what I do is I look at what happens when I have I to the third, okay? Because I to the 35th, that's the same thing as I to the 32nd times I to the third. I to the 32nd is the same as I to the fourth, so that's just a 1 times I cubed, which is -I. Okay, and then similarly, I to the 18th, I take 18, divide by 4, it goes in 4 times, I get a remainder of 2. Okay, so what this means is I to the 18th is, I can think of that as I to the 16th times I squared. I to the 16th is the same as I to the fourth, so that's just 1, times I squared, which is -1, so this is -1.